Sure, our managed reliability controller, the MRC, like I said before, we have 4 host ports now at 8 gigabits per port on fiber channel. We've moved from a gigabyte of memory to 4 gigabytes of memory on our main controller board type of thing. So we've boosted our cache in our controller, okay? We've introduced the supercap subassembly, okay, and that's going to eliminate the battery subassembly so that we do not have to worry about maintenance of batteries over a 5-year period. The supercaps are good for 10 years, okay, and we'll be able to run for a couple of minutes while we flush our cache to an SSD drive in the MRC when we lose power. So that's pretty much that in a nutshell.
And generally everything is faster, a lot faster, just about everywhere. There's more, and the more connectivity. I haven't even written the white paper on it yet. Gives us a lot of flexibility in terms of configurations, and
Yep.
and we can, I believe, save a lot of money for people on the way they connect things. Minimal amounts of switches, lots of direct connects, and without losing the ability to access a whole lot of storage on a number of ISEs. Those extra ports and their speed just give us a lot of flexibility and power that we're just beginning to explore how powerful it is. We've done some base measurements of the system right now, running the firmware, and as well as raw measurements that just measure the limits of the hardware to give us some idea of where you could go if you had the most
Right.
optimized software. And we're doing a lot of analysis and understanding of how to use the new mirror bus that's different than the mirror bus on the first product. It's called a non-transparent bridge. We're using a different processor, and so it uses a different technology for bridging, and we're bridging on a PCIe bus.
Right.
And it's quite fast. One of the big things is the ability to add a whole lot of extra disk drives on the back end so that we can get large amounts of capacity back there. And we've measured some performance on those things as we've added more and more what we call shelves. And the performance has held up, even when we're measuring all the way to the end of a chain, where you daisy chain these shelves through cables. And the performance of the drives don't seem to drop off, even though they may be further out on the chain. So what we're seeing is that there's a whole lot of ability to have not only extra capacity, but a lot of IOPS behind the extra connectivity we have in the front. So we're just, the number of possibilities to explore is just almost overwhelming.
On our CPU architecture, we've moved to the x86 architecture. And right now we're set at 1.7 gigahertz speed-wise with two dual cores and 2 threads per core, okay? And so we have that base to work from. You couple that with 4 ports of fiber channel on our host side and 24 ports of SAS at 6 gigabits on the back side, as we call it, type of thing, with 4 gigabytes of main memory, okay, and that produces one powerful controller.